Our ratio unit begins with the basic ratio, okay? You need to understand what a ratio is. So at the very top of your notes, notice I have 3 triangles and 4 circles, okay? We are looking at a ratio of triangles to circles. So a ratio is a comparison of 2 quantities by division. Okay, you're going to see where that division comes into play in just a minute. Ratios will always compare 2 quantities. So if I'm looking at that example above, I'm comparing 3 triangles and 4 circles. So what is the ratio of triangles to circles? What would I say? Triangles to circles. Cooper?
1.
We're not reducing it because we can't. So what do you see? How many triangles?
4. Or 3.
That would be circles to triangles. I want the
3 to
ratio.
4.
Yeah. Okay. Notice how I had to reword that and repeat it a couple times. Be very careful. Ratios have to be listed in a very specific order. If you tell me it's a 4 to 3 ratio, what I'm then comparing is circles to triangles. I want to compare triangles to circles. So 3 to 4. Okay, so what we're going to do is I'm going to write 3 triangles to 4 circles. And I'm going to show you 3 ways that we can write a ratio. Okay, one of them you saw in the video that I used to introduce ratios to you. Okay, that would be the 3, and then that's what we call a colon, 4. Okay, so 3 to 4. We say 3 to 4. We don't say 3 colon 4. That's weird. Okay, we just read it 3 to 4. We can also write a ratio 3 to 4, the way that we actually say it. The third way that we can write a ratio is a fraction, a 3 to 4 ratio. You still read it 3 to 4. You don't read it 3/4. You read it as 3 to 4. Say again.
Does the bar have 3 different meanings?
So Eli just said, does the bar have 3 different meanings? Kinda, yeah. Because in this one, I'm comparing a part to a part, but a fraction sometimes compares a part to a whole, but a division bar, or that fraction bar, can also mean division. That's why when it says a comparison of 2 quantities by division, that's where that division comes in, okay? So these are 3 different ways to write a ratio. Now you're going to know if you're doing a ratio in a fraction form because it's going to be comparing 2 different quantities. Okay, it's not going to just be some random fraction up there and you have no idea what it's comparing. Okay, it'll tell you. All right, well, what if I want to do equivalent ratios? Okay, we're going to look at one. We're going to spend more time on this tomorrow, but we're going to look at this one example because I want you to see what an equivalent ratio looks like. So the very first thing says multiply or divide both terms. Okay, terms are the things that you're comparing. So like triangles and circles or something, okay? In this case, what would my 2 terms be? Apple pies and cherry pies. So we're going to multiply or divide both terms of the ratio by the same number to find an equivalent ratio. So if I was keeping an equivalent, this kind of is like our video that we just watched, how it was like 36 words to 6 words. And then she said for every 6 words, he spoke 1 word. Okay, those are equivalent ratios. They're the same amount. It's kind of like an equivalent fraction. So equivalent ratios are very similar. If I have 3 apple pies to 7 cherry pies, but then I double the amount of apple pies, that would be 6 apple pies. To keep the same ratio, how many cherry pies would I then have? 14. If I had times 3 the amount of apple pies, that would be now 9 apple pies. But to keep an equivalent ratio, that would be how many cherry pies? 21. Do y'all see what's happening? Okay, so what would my next apple pie be? 12, and then cherry pies would be 28. And then 15 and 35. And then I would have 18 and 42. If I were to put a fraction bar Notice these are now all equivalent fractions. Y'all see how that works? So equivalent fractions are very similar to equivalent ratios. The only difference is with ratios, it is comparing specific things. I'm comparing apple pies to cherry pies. It's not a part to a whole. Okay, it's a part to another part. It's my apple pies, which is different than my cherry pies, but they look similar to equivalent fractions. Okay, let's go below and let's see the problem that it's giving to me. So it says 8 students of the class of 32, 8 out of 32 had ice cream at lunch. Okay, what is the ratio of the students who did not have ice cream? First, what is the ratio of students that had ice cream to the total number? What would that be? 8 to 32. Whoa, that's not right. That is not a pen. Let me get my pen. There we go. My ratio of students who had ice cream is going to be 8 to 32. Okay, if I want to know if I were to reduce that, okay, what would that reduced ratio be? Yes, it would be a 1 to 4 ratio. See how this is kind of similar to fractions a little bit? Okay, but if I want to know how many kids didn't have ice cream, what would I have to do, Cooper? Well, what would I have to do to figure out how many, so if I have 32 kids, okay, 8 of them had ice cream. How do I figure out how many did not have ice cream? Subtract. It's actually very simple. Okay, think about it for a second. Okay, 8 students out of the 32. Imagine we have 32 people in here and only 8 ate ice cream. How many students did not? 24, because you're literally just subtracting.
1 to 6.
So you're doing 32. Hold on, we'll write the ratio in a second. 32 minus 8 is 24. So 24 students did not have ice cream. Okay, so 24 out of 32 is equal to 3/4. Mm-hmm. Notice how my fractions kind of relate with ratios. Now, your practice is not going to involve as many fractions. I just want you to see the relationship because fractions are still relevant. They didn't just go away because we moved on to a different unit, okay? You can still use fractions in this format working with ratios. All right, let's look at the jelly bean table. It says, what is the ratio of blue to green jelly beans? This is kind of what your practice is going to be like. So you might have a table, maybe you have information. One of them, you have a bunch of marbles and you have to color them certain colors and then answer questions just like this, okay? So pay close attention to this part. It says, what is the ratio of blue to green jelly beans? So the first thing I want to do is find my blue to my green. Do you think I can say 3 to 7?
No.
No, because what is that comparing? That would be green to blue. It says blue to green, so I have to make sure I write blue to green. That's one way to write it. What's another way to write that ratio?
The fraction bar.
The fraction bar, 7 to 3, or the colon, 7 to 3. I say 7 to 3 for every single one of them. If you wrote any 3 of those, you would get credit for it because they're all technically correct. There's 3 ways to write one. You pick what you like. What about red jelly beans to the total? How many red jelly beans do I have?
6.
I have 6 to the total. How many total jelly beans are there? Say it again.
25.
25. So 6 to 25. Can that be simplified? Is that as low as it goes?
Yes.
That's as low as it goes because I can't divide 6 and 25 by anything other than 1. Okay. So now I can write this 2 other ways. I can write it like a fraction, 6 to 25. I can also write 6 to 25 with a colon. Okay. This is what you're doing on your practice today. You're literally answering questions just like that, okay? The last page in your packet does require you to color, so that's why I had color pencils on your what you need today. If you need to borrow from somebody, you can borrow. I don't have a whole lot left. It's all been picked over. I have a lot of white color pencils. So just borrow from people at your table, kind of work together.